Hello everyone, how are you all? So today we'll do a very nice topic which is called the growth rate. So you all know that in economics it is very important to know what is the growth rate or the decay rate of a function. So let us start it and view it through an example. All right. So so what we know about growth rate is this, that growth rate of a function is nothing but the change in the value of the function divided by the original value. Okay. So for example, if gx denotes your original function, okay, or you can call it as qx. For example, it is the demand function. So suppose it is representing your original function, then what is the growth rate of this function? So the growth rate of the function is defined as gx, which is change in qx, which is q dash x divided by qx. Now what is q dash x? Q dash x is nothing but the derivative of qx with respect to x. What do you mean by derivative of qx with respect to x? That is rate of change of qx. Okay, what happens to qx when x changes by 1 unit? That is, it increases or decreases by 1 unit. If you're understanding the concept, please type in the chat box. Okay, so we are going to see how the growth rate of something is calculated in economics. All right, so let us do it an example. Find the growth rate of A is equal to K E R par T, where K is a constant. Obviously, this R is also supposed to be a constant. So K comma R are constant. So basically, we have A, which is a function of T. Okay, basically T stands for time, ERT. So what is the growth rate? So the growth rate is nothing but A dash T divided by AT. Change in A divided by change in original value of A. So what is change in A? So what is the derivative of AT? K will be a constant. It will be written as such. Then the derivative of e power RT. So d by dt of e power RT is e power RT into d by dt of RT. This is called chain rule of derivatives. So e power RT, and then I take the constant out, derivative of t is 1. So this is R ERT. Okay, and AT is nothing but KERT. So in this kind of equation, R denotes your growth rate. Okay. For example, if A is your demand function of a product, so and if A is equal to, for example, 7 times e power 3t, so your growth rate will be equal to 3. So every year, with every year, the growth is going to be 3 times the previous year. That is what growth rate is. Okay, let us go through one more example where we have to find out the growth rate. Okay, so suppose we have to find the growth rate of profit at t equals to 8. So this pt is my growth rate function. So we have a very wonderful way. Let us see. So we have pt is equal to 25,000 e power 1.2 t power 1 by 3. Okay, so to know the growth rate, we have to calculate P dash T. So what is growth rate? Growth rate is P dash T divided by PT. So there is one more way in which we can do this. Okay, we take log on both the sides. So we have log of PT is equal to log of 25,000 e power 1.2 t power 1 by 3. Okay, now we have very nice property of logarithm. First property of logarithm is if we have log of a into b, that is log of a plus log of b, and if we have log of a power m, the power comes out. All right, so let us see how we are going to use these two properties in solving this question. Okay, so first of all, we are going to simplify this. So this is going to be log 25,000 plus log e power 1.2 t power 1 by 3. Okay, so again, it is going to be log 25,000 plus, let us take this power outside, 1.2 t power 1 by 3. Okay, this whole thing is power, it will come out log e. And what is log e? Log e is 1 because base is 1. So we will have log pt is equal to log 25,000 plus 1.2 t की power 1 by 3 into 1 because log e is 1. Now differentiate both sides. differentiate both sides with respect to t. So what is going to happen? Derivative of log of something is 1 upon something. So derivative of log pt is 1 upon pt. But according to the chain rule, we have to differentiate pt once again. So that is going to be p dash t. All right. And what is this? This is a constant. Log 25,000 is a constant. So derivative of a constant is 0. Okay. It is not 25,000, it is 2,50,000. Okay. So it is going to be 0 plus, and then this thing, the derivative of this is going to be 1.2, then 1 by 3, t power 1 by 3 minus 1. All right. This is called power rule of derivatives. So this thing is the growth rate. So growth rate is going to be 1.2 t by 3 whole power minus 2 by 3. And finally, we have to have the time t equals to 8. So 1.2, 8 upon 2 whole power minus 2 by 3. So 1.2, 2 upon 8 power 2 by 3. This is 1 by 4. So 1.2. So 1 by 4 is 1 by 2 square whole power 2 by 3. And this can be calculated using a calculator or a digital online calculator. So that is how you find out the growth rate of a function. Now to calculate the growth rate of a function, you should know the formula and you should be very, very comfortable with calculation of derivatives, because that is why derivatives are very important in economics, because derivatives indicate rate of change of something with respect to time or with respect to another variable. So I hope you like today's video and you got to understand what is growth rate of a function and how do we calculate it. Thank you.